Hi guys, Mr. Thompson again. This week I'm doing lesson 10, sessions 1, 2, 3, and 4 with you. So I'm your guest teacher for this unit. It's a short session. It's 4 pages, 183 to 186. And as usual, we'll start off with a little brain bender to get you thinking. So up here you see that we have 4 squares, 4 letters in them, as you're probably used to. And what's the same and what's different about the expressions in each of these 4? Box A is 14 minus 9. Box B, negative 14 plus 9. Box C, 3 plus 2. Box D, negative 3 plus negative 2. So take a few seconds, think about that, write down some ideas, and when we come back, we'll talk about what's the same, what's different about it, see if you came up with the same thing as we did. All right, welcome back. So, some similarities. Did you notice that all the expressions have a value of 5 or negative 5? So if you said, hey, these answers are all the absolute value of 5 or negative 5, then good job. What else? Well, you'll notice A is the only expression there that's subtraction. We're adding some negatives in number D, but it's not a subtraction problem. B is the only expression with a negative integer and a positive integer together. C is the only expression with 2 positive integers. And that means, of course, D is the only expression with 2 negatives. Now you'll notice that A and D end up as subtraction problems because adding a negative number is the same thing as subtracting, as you learned previously to this grade. And what else? Negative 14 plus 9 keeps you in the negative range. Negative 3 plus negative 2 starts negative and stays negative by going even more negative. So if you found some of those, good job. Let's take a look at our page 183 and see what we have. Let's look at these problems and work them out together. So, our first problem, but a diving platform. Now we're dealing with integers here, so this should be review from last week. This should be easy peasy, right? The pool's diving platform is 10 meters above the water surface. The bottom of the pool is at negative 5 meters relative to the surface of the water. So what's the distance between the diving platform and the bottom of the pool? Give that a couple seconds, think about it, work it out, see what you come up with, and I'll be right back. All right, welcome back. So let's take a look. What are we dealing with here? Well, one way we can solve this is with a number line, right? So let's pop a number line up here and see what it looks like. So here we have a number line. 0 represents the surface of the water. Negative 5 represents the bottom of the pool. And 10 represents the top of the diving board, right? Well, an easy way to find this is to take the distance from positive 10 down to 0, which is 10, and the distance from negative 5 up to 0, which is 5, right? Now, how do we know that this distance from negative 5 to 0 is a positive 5? Because distance is always positive, right? You learned that before. If you live 5 miles away from school in one direction, and your friend lives 5 miles away from school in the opposite direction, he doesn't say he lives negative 5 miles away from school, right? It's all measured the same distance. You're measuring positive distance whether or not you're located in one direction or the other. Same thing with a number line. So how far are we? We are 15, aren't we? We are 15 meters from the top of the board to the bottom of the pool. Another way we can think about that is if you're finding the distance between something, you're subtracting, right? So if we're finding the distance between 10 and negative 5, what do we have to do? We have to subtract to find the distance between those. So we have 10 minus a negative 5. Ooh, you know that subtracting an integer is the same thing as adding its opposite. So the opposite of negative 5 is a positive 5. So that means 10 minus a negative 5 becomes 10 plus 5, and 10 plus 5 is 15. Now the same concept that we use with integers we can use for rational numbers too. Let's take a look at our next page, page 184. So we're looking back. What's the distance between the diving platform and the bottom of the pool? Well, we know that question, don't we? We just found that out. Distance is 15. Because, how do you know? We can write it like this. The diving platform is 10 meters above the surface, and the bottom of the pool is 5 meters below the surface, and 10 plus 5 is 15. Just dealing with adding distances, right? Let's look at this next one. Look ahead. In the try it, you found the distance between two elevations represented by integers. You can also find the distance between non-integers. So explain how you can use the number line, this number line right here, to find the distance between 4.5 and negative 3.75. And if you think about this just like the diving board question, it looks pretty simple, right? We could write that down like this. The number line shows that there's 4.5 units between 4.5 and 0. Now it also shows that there are 3.75 units between negative 3.75 and 0. So since 4.5 plus 3.75 is 8.25, the distance between 4.5 and negative 3.75 is 8.25 units. Works out pretty easy, doesn't it? Question B. You can use both the expressions, the absolute value of 4.5 minus a negative 3.75, and the expression negative 3.75 minus 4.5 to find the distance between 4.5 and negative 3.75. Why is that? Well, for one thing, we're finding absolute value. And you know that absolute value is always positive. Doesn't matter what's inside those bars, it always turns out to be positive, right? Because absolute value is measuring distance. So what's the difference between these two expressions? Well, you're both subtracting, and you're subtracting 4.5 and negative 3.75. It's just the order that you're subtracting them in, right? So the order in which you subtract them doesn't make a difference if you're finding the absolute value. And why is that? We can write it like this. Because the distance is always positive. The distance between 2 points is the same. It doesn't matter which one you start with. In other words, if you use 4.5 and count all the way down to 3.75, or if you start at negative 3.75 and count that all the way up to positive 4.5, it's going to be the same distance between them, right? If you walk from your house to your friend's house across the school, and you're positive 5 and he's negative 5, it's going to be 10 units distance each way. Doesn't matter which direction you're going in. So you're subtracting, it says, to find the distance between 4.5 and negative 3.75. Now, with absolute value, you get the same answer. You take those absolute value bars off, you get the opposite answer. Negative 3.75 minus 4.5 is the opposite of 4.5 minus a negative 3.75. This makes sense if you think about it using a number line. If you start off at negative 3.75, you're already starting off on the negative side. If you're subtracting 4.5, you're just going more negative, right? You start there, you move negative, and you're keeping moving negative. So you end up at negative 8.25. Now, if you do that the other way around, you start off at positive 4.5. If you subtract a negative, that means you're adding a positive. So we've gone up to 4.5. Now we're going further up, 3.75, which gets you positive 8.25. So the order in which you subtract does make a difference. And we can write that just like that. Why is it the opposite? Because you're traveling the same distance with both expressions. You're just traveling in opposite directions. The reflection we'll leave for you because it's a very personalized thing. So let's move up. to page 185, talking about a graphic organizer. Hooray! Let's take a look at what our graphic organizer looks like. Looking at absolute value. Everything we know about absolute value. It's time to write it all down. So, take a few minutes, write down first, what is absolute value? What is it? What do you know about it? Give some examples and some not examples. And pause me for a second, come back, and we'll talk about it. Okay, welcome back. So, did you fill it out? What'd you think? Let's go by the what is it first. What's a good definition for absolute value we could come up with? How about the distance of a number from 0 on the number line? Doesn't matter if it's a positive number or a negative number, it's always going to be a distance from 0. And because it's distance, it's always positive. That'll work. As a matter of fact, that also answers a few things that we know about it too, doesn't it? What do we know about it? Well, it's never a negative number. And its symbol are those two bars, right? Think of it this way. Those two bars are like when you're showing the distance of something, you say it's from here to here. It's like you hold your hands up like that. That's like what those bars are. It's the distance between two things. Think of it like that. That's how I always thought of it. So what's some examples of absolute value? Let's look at some examples. Well, let's see. We have the absolute value of 4 is 4. The absolute value of negative 4 is also 4. What's the absolute value of 0? Well, if it's the distance of a number from 0, the distance from 0 of 0 is 0 units, right? So the absolute value of 0 just stays 0. You can also put expressions inside absolute value bars, like the absolute value of 4 minus 5, which is the absolute value of negative 1, which, if you take those value bars off, just becomes positive 1. There's a couple examples of that. Non-examples, well, anything that's not an absolute value is not an example, right? So 4 minus 5 is negative 1, no absolute value there. 3 minus 3 is 0, nope. And 2 times 3 is 6, well, we're multiplying there, that's totally off. So all those are examples of what not absolute value is. Let's look at this question down at the bottom. Is negative 4 the absolute value of 3 minus 7? And explain. Take a few seconds, think about it. What do you think? Is negative 4 the absolute value of 3 minus 7? Let's think about what the question's asking us. Well, the quick answer is no, it's not. And why is it not? Because the way it's phrased, the absolute value of 3 minus 7, you can write as the absolute value of 3 minus 7, which is 3 minus 7 in those absolute value bars. Now 3 minus 7 is negative 4, but negative 4 is still in the absolute value bars. So if we take that negative 4 out of the bars, it becomes positive 4. So the absolute value is always positive. So negative 4 would not be the absolute value. Positive 4 would be the absolute value. Let's roll on page 186. Okay, another example. The top of a molehill is 4 inches above ground level. The bottom of the mole's burrow, at the bottom of the molehill, is negative 9 inches relative to ground level. So what is the distance between the top of the molehill and the burrow? And show your work. Give it a few minutes, think about it, work it out, show me what you have. We'll come back and then we'll talk about it. Okay, welcome back. So, what did you get? First of all, we can look at our data, right? For one thing, we're finding the distance between the top of the molehill and the burrow. So if our molehill is 4 inches above ground and negative 9 below ground, the distance between means you're finding the difference between the two. And finding the difference between the two means you are subtracting. So you just subtract those two numbers. So we have to find the absolute value of the difference of 4 and negative 9. So we can do that, right? Just like we did earlier on. We can find the difference by subtracting. We just subtract those two numbers. And what we come up with looks like this. We have the absolute value of 4 minus a negative 9, right? Because we're subtracting 4 and negative 9. Subtracting a negative becomes a positive. So 4 minus a negative 9 is the same thing as 4 plus 9. And 4 plus 9 is 13. The absolute value of 4 plus 9 is also 13. So that solves that. But what if you did it the other way around? What if you did negative 9 minus 4? Would that be any different? Let's take a look. If we did it the other way, you'd have negative 9 minus 4. Now, if you take negative 9 minus 4, you're starting at negative 9, and then you go 4 more backwards. So you have negative 13. But it's the absolute value of negative 13. Take that out of the bars, and that becomes positive 13. So either way you look at it, whether you're going from one direction or the other direction, your answer is going to end up being positive 13 as the distance between those two. So, check the answer, it says. Let's check this answer. How would we do that? Well, we can start off with a number line. Okay? So with this number line, we can say, all right, we have 4 in the positive direction. That's the top of the hill. We have negative 9 in the negative direction. That's the bottom of the hill. So we can think of it like this. If we take the absolute value of 4, which is 4, the absolute value of negative 9, which is positive 9, add those two together, negative 9 absolute value plus 4 absolute value is 13, which is the same answer we got. So we must be right. There's another way to look at it too. Let's look at it this way. If we think of it as moving along a number line, if we start at 0, we add 4, okay, and then we subtract 13. So we're going 4 along the positive direction, and then 13 along the negative direction, crosses back over the 0 into negative territory, and it ends up at negative 9, which is another way of saying positive 4 minus 13 is negative 9, which is what we found out. We're just finding it the other way around. So 2 ways we could solve that, and 2 ways we can prove it. So, like I said, today was short, quick, and easy. So tomorrow, we're going to be getting to lesson 2, more of the same, a couple more pages, a couple more practice problems. And that's getting more into rational numbers, getting away from the integers a little bit. So I'll see you then. So see you later, guys.